那这位他的特长就是说，即使你完全不会写程式，他4个小时之内就可以让你把一个站砍下来，这样。所以他的特长就是这个把各种各样子的人，可能只是关心他的政府或者是关心他的某一个网站，但是呢不会写程式，但他有一套方法能够让你马上就变成砍站的专家。所以我们就直接就进入他的 talk， 谢谢。
Hello everyone, my name's Henare Degan. I'm a civic and democracy hacker at the Open Australia Foundation. And while James in the previous talk took us to 2035 and the wonderful standards future, I'm going to bring us back to today and what we can achieve with scraping. Specifically with Morph, the Open Australia Foundation's free and open source civic tech scraping platform that we run for the international civic tech community. Today, I'm going to teach you about the history of Morph, why we created it. I'm also going to show you how you can add your own scraper to Morph and use it in your next project. And finally, I want to finish with a question for you all about the future of tools like Morph. So first up, why did we create Morph? Well, to do that, I will tell you the story of planning alerts. And we need to go back to 2009. Planning alerts was the second major project of the Open Australia Foundation. What planning, it's been through a number of iterations since then. It's got some major new features. It now looks like this. The premise of planning alerts is simple. You put in your street address, you put in your email address, and then whenever there's a development application in your area, you get an email, like this one. If you click on one of the applications, you'll see a page like this, and there's a page like this for every single development application. At the top, there's a street address for this development application. There's a map and a street view image of the location, a description. So in this case, the proposer wants to demolish the existing structures, the houses, I guess, and erect 6 two-story townhouses. At the bottom of that, you'll see that there's a link to more information, and that takes you to the official government website, where they might have plans or more information. And down the bottom, you'll notice that it says 9 comments. If we scroll down the page, we can see one of those comments. Nat B writes, "Please, please, please do not approve this development. It is criminal to demolish a beautiful period Federation house to build these townhouses." So Nat B really doesn't want this to proceed. And they've done that by adding a comment on planning alerts. The really important thing about comments like this on planning alerts, and all the comments, is that it says delivered to the planning authority at the bottom there. That's because we send each and every one of these comments to the council as an official submission, so that people can impact what's going on in their built environment. And we know that comments like these have had an impact. They have stopped really bad developments from going ahead. They've improved ones that needed improvement, and people have supported ones that they wanted to see proceed. And at the Open Australia Foundation, we think that's pretty cool. And we're not the only ones. Planning Alerts is by far and away our most popular project. Since it launched, we've sent out over 34 million development applications across Australia. It's been used by over 2 million people, and every week this increases. We send out tens of thousands of email alerts. Just recently, it says 80,000 there, but just recently we broke 100,000 applications in just 1 week. So, how do we enable all of this civic tech goodness? Well, in Australia, there are 500 local governments, and each one of those publishes their development applications in a different way. Some not at all. Some in PDF. Cue laughter from the open data audience. Lots of people put it online on a web page, and that's okay, and even fewer still put it online in an API, which is really awesome. But by and large, we're dealing with web pages. So how do you deal with web pages? Scrapers. So we cover 65% of Australia's population, and we've done that by writing scrapers for 145 different councils. And so that's great, but we've still got a long way to go, obviously. When we first started, we had even fewer. We had about 30. Because we've got 500 councils to cover, we had to go out to people and ask them to participate, to contribute scrapers. Now, for each one of these, you need to write some specific code. Some can be quite short, some can be a bit longer and a bit more involved, but each one needs some unique code, basically. And for us to accept contributions from outsiders, from volunteers, we don't know what their code's going to do. It's got to run on our server. We don't want it doing anything naughty, right? So to accept a contribution from a third party, we had to do a full code audit. And doing a full code audit is almost like writing it yourself. And so we didn't want to do that. The following year, in 2010, after we launched Planning Alerts, ScraperWiki came along. Hooray, ScraperWiki. So ScraperWiki allowed anyone to code in their browser, submit that to ScraperWiki. It would run the scraper for you, store all the data, and make it available in an API. So that was great. So over the next several years, we progressively moved all of our scrapers over to ScraperWiki. Unfortunately, ScraperWiki is a startup. It's a business. And so they couldn't find a business model. And unfortunately, they announced that they'd be shutting down that service in 2014. So we had two options. Either we move all of the scrapers back to our server and go back to the situation where it was really hard to accept contributions. And we did start to do that as a contingency. Or we could just rewrite ScraperWiki. How hard could it be? Obviously, that was crazy, right? Well, a couple of things had happened since ScraperWiki was created and about the end of 2013. First of all, GitHub had become the place for you to put your code and to collaborate on code. And secondly, Docker had become a thing. Docker is a bit of technology that allows you to run really lightweight containers of isolated applications. Just the thing to run scrapers, right? So, over the Christmas holidays in 2013, Matthew Landau, one of the co-founders of the Open Australia Foundation, instead of, having a holiday, decided he'd give it a try. And after a couple of weeks of hacking, he came up with a really early version of this, morph.io. So morph carries off where ScraperWiki left off. It allows you to run your own scrapers in any language, or any one of 5 languages: Ruby, Python, PHP, Perl, and Node.js. You continue to put all your code on GitHub, like you do today anyway, right? We take that code, we spin up a Docker container, we run it for you on our servers in the cloud. We store all of the data, we make that available through a simple and powerful API. You can set those scrapers to run regularly, and we'll let you know if there's a problem with them. So that's great, but the most important question for us was, did it work for planning alerts? Did we move all of our scrapers over to morph? If you answered yes, give yourself a pat on the back. Yes, these are all the scrapers that for planning alerts. So now every single scraper that we run for planning alerts is over on morph. So now that's the kind of background of why we created morph. It's opened up so that anyone can use it. And now, against my own better judgment, stand back. I'm going to do a live demo. Fingers crossed, everyone. Please, please. OK. So here's morph. So you go to morph.io, and first thing you need to do is sign in. Hope everyone can see it. Make that a bit bigger. So I click Get Started. Because I've already authorized my account with GitHub, fingers crossed, remember, it should sign me in automatically. Slowly, yeah. It's just GitHub. They don't have very good servers. We've all been there. If you hadn't already signed up, well then it would ask you to authorize your GitHub account so that Morph can create repositories and things like that. So you just click authorize, and then you'd go back to Morph. Yay! Okay, and so the next thing you do is you just click New Scraper. We're on a bit of a small screen here because I'm on the projector, so I just had to pop out the menu here. This is going to take just as long again, isn't it? Thank you, James. See, sometimes he's an ally, and sometimes he lambasts scraping just before I give my talk. Yeah. Okay, so... Yeah. Just please stop torrenting some television programs. I love those Taiwanese game shows too, but just, hold off until after the talk. Okay, well, while we're waiting for that page to load, we first need to decide what we want to scrape. So what I thought we'd scrape is the GovZero data portal. So I want to keep an eye on GovZero. They need some accountability. So I want to make sure that they're adding more open data sets to their data portal. So what I want to do is I want to collect this number every day to see if is it going up or are they taking data off their data portal. We all know it's going up, but yeah. So that's the page we're going to scrape. So here we go. Our new scraper page is loaded. We decide what language we want to create our scraper in. There's the 5 different languages. I'll keep it in Ruby. You can store your scraper in a different organization on GitHub. So I'll put it in our test scrapers. We give it a name, so gov0 scraper. And a description is Henare crazy enough to do a live demo. Oh, yes, he is. And I click create scraper. So what morph does, it goes off to GitHub. It creates a new repository on GitHub. It puts in a template with a scraper, and very slowly. Yeah. GitHub's the problem. Okay, so while that's doing that, then here's our dataset page. Okay, so I might be crazy enough to do a live demo, but I'm not going to do live coding. So here's one I prepared earlier. Okay, can everyone see that? All right. I'll walk you through what happens in a very simple scraper here. So right up the top here in Ruby, we import 3 different libraries. The first one is a scraping library. The second one is the old ScraperWiki library that helps us save the data to a database. And date, because, hey, this is Ruby, and it's really complex to get today's date. So first of all, we've got the URL, which was this page. We then create an instance of the mechanized library. We fetch the page, and then out of the page from this view header, which is something that I inspected in my browser earlier, looking into the DOM of the web page, we do a bit of text manipulation to get just the number, and then I save that to the SQLite database. The unique key is the date, and these are the number data sets and today's date. So what I want to do is I want to get the scraper running every day, running it all at the moment. I hope so. I do have one I prepared earlier. I'm not that crazy. So after I create a scraper, the scraper looks like this. It's got a different name, but that's all right. Ignore that. If I clicked run on a template, it wouldn't do anything. But I've added my code to GitHub, and I've committed the code. So when I click run, what morph does is it boots up a Docker container. First of all, it injects the programming language. Then it injects any libraries from that programming language that you've asked for. And then finally, it injects the scraper code, and then it runs that. And then you get some output, any output that you might have done on your scraper. And then down the bottom, you'll actually get the data that the scraper has saved. It's really simple to get access to that data. You can click download table as a CSV. And that'll allow you to open it in your big data analysis program, or some of you might call it a spreadsheet. You can download the raw SQLite database, or you can use the API to access the data. I said before that the API is simple and powerful. It's simple because it's very simple. It's powerful because you can use SQL right in the API. So you can write SQL here, anything that SQLite will accept, and it'll actually query that on the morph.io database for your scraper, which is really cool. And then it'll output it in something like JSON. So once we've run our scraper, we might want it to set it to run automatically. So I'm sorry, I'm chopping and changing here because this is the one I prepared earlier. We click Set Settings. It takes us to this page where we click Auto Run, so that'll mean it'll automatically run once a day. If your scraper throws an exception or there's another problem, you'll get an email about that. There's a couple of other interesting settings on this page as well. These secret environment variables. So if you've got a password or an API key that you want your scraper to use, you can add that here. Password. Whoa, secret. So if you don't want to, we shouldn't commit that to your public GitHub repository, you can add it here. I'm not going to add one now. And also, you can add a webhook. And this was a contributed feature from my society that they needed for their Every Politician project. So after a scraper finishes running, it'll ping that webhook, and you can get another application to do something. And that's a great time to remind everyone that Morph is an open source project. And my society knew that. And so they just went ahead and said, hey, would you like this feature? And we said, yeah, cool. And we kind of hashed that out. And it's now live on Morph, which is pretty cool. OK, so now I've shown you how to add a scraper, a really simple drive-by scraper that's going to, you know, in 2035, when it's finished adding to Morph, it'll be able to track the number of data sets on the GovZero scraper data page. You've also seen earlier in my talk that Morph can power a really complex and detailed application like planning alerts. And on Morph, there's over 5,300 scrapers, and they run the whole range from, you know, powering big civic tech applications like planning alerts through to something fun that we tried to write in a talk. So you can find these, and we have this quite simple and powerful search as well. As you may be able to tell, I'm a bit of a food fanatic. I really love your food here in Taipei, by the way. Top notch. So if I search for food, you can see that there's actually 32 scrapers relating to food that people have written all around the world. And they've made them open source and put them on Morph. This one I didn't even know about until I was researching this talk. Someone in Cornwall has scraped the food safety inspection data. And so if we have a look at that scraper, we can see that it's scraping from a government website the safety of JB's snack bar in Cornwall, presumably. So that's kind of interesting, and that can be used to create applications like this one. So a friend of mine in Sydney created this for Australia. Got Gastro. I hope you don't. You can search for food safety places on his website. It'll show you the places that have had problems near you, like the Crispy Inn Bakery that failed to comply with this food standards code. And so heaps of little applications are springing up that are powered by Morph, and that's really cool. Another thing you can do with the search is that we track every domain that your scraper hits. So you can search for something like gov.au, and that'll show me every scraper that's scraping an Australian government website. You can narrow that down, and I can go to nsw.gov.au, which is my state, and it'll show me all the scrapers that are scraping data off government websites in my state. So there's 44 here. So that's quite interesting. So I want to finish my presentation now by talking about the future of tools like Morph. We've been talking about the future a lot in the previous two talks, so I think we've got some interesting discussion over dinner tonight. To do that, I want to talk again about this website. I'm so glad that it's getting a bit of talking about today. Rada4U. So Rada4U looks a lot like one of our websites. They vote for you, and that's because it's a fork of our website that we help build with local partners Apora in the Ukraine and Open North in Canada. And to create this, we had to scrape MP data and vote data. And to do that, of course, we did it on Morph. So straight away, all the data is available on Morph for anyone to download, and all of the code for the scrapers is open source. And that's great. But we went one step further, and we contributed that data to the Every Politician project. And we did that not just because we're good open source citizens, but because it had a real benefit for our local partners Apora in the Ukraine and for us. Someone else was helping us maintain that data. And so that was really important because, like so many civic tech projects, the budget for this was tiny, and anything we can do to get a bit of help is going to help, right? Of course, if the barrier for us to contribute that data had been too high, we couldn't have afforded to do that as well. So it was really important that every politician made it possible for us to contribute that data and lowered the barrier of us to participate in their project as well. So that's really cool. There was like 4 or 5 different organizations here collaborating, using Morph, using every politician, using Popolo Standard as well. And all of this spontaneous and opportunistic collaboration between organizations made me kind of think about the history of civic tech collaboration. So in the beginning, we forked websites. So some very smart people open sourced the code to some early civic tech websites like They Work For You. And Open Australia, that was the first project that we created, was a fork of They Work For You. And then the next logical step after you fork is to go, well, we should be collaborating on these code bases. So some smart people then created platforms. And Fix My Street by My Society is probably the oldest and most redeployed examples of one of those platforms. And there are others out there as well. More recently, we've been experimenting with the idea of components, and the Populous Federation is one example of that. But when I looked at every politician and Morph, and I looked at some of the components of Populous, like Write It and Cuttlefish, which to my knowledge haven't actually been redeployed, but are being used as shared services, it got me wondering whether we're entering a new era of shared civic infrastructure. And if we are, well then maybe we can look after those projects like infrastructure for other open source projects. So if that is the case, and that is my question to you, the next questions are, what's next to build? Every votes, Write It global, and the most important question is, how can we build it? And how can we build those tools so the barrier of entry for other people to contribute to those are so low that it just makes sense, it doesn't cost anything to that project, and we can all get back, as civic tech practitioners, to building the real value-add services that make a difference for citizens. Thank you.
Wow, that was very, very nice. Learned a lot.
Thank you.
Yeah, so, well, because of the time, again, I'm going to ask you to just spend maybe 20 seconds on each of these ones. So the first one, we see that GitHub actually has unlimited private repository now for $7 a month. So do you plan to work with private repositories and private datasets? 如果这个就是你砍在那个城市不想公开的话，这样可以吗？
So right now, everything on Morph is publicly accessible. We have considered the possibility of creating private accounts for people that want to maintain that, but to be honest, that was a business model that didn't work for ScraperWiki, so there's nothing to say that it'll work for us. And also, everything on Morph being public means that it is the civic tech scraping platform. Whenever you download data on Morph, that's actually logged as well. So you can see people that are accessing your data, and that gives you an opportunity to collaborate with those people. And at the Open Australia Foundation, we're about making civic tech. So at the moment, I think that that's a much more valuable proposition for us, is making that open and making a statement about open collaboration on civic tech projects.
So are you publishing the Docker files you generate or Docker images as an alternative? 它做出来这些 Docker image 它有在公开吗？
Everything is open source for morph.io and is available on our GitHub account.
So is there any limitation of the size of the downloaded SQLite database? 那个有空间限制吗？
There's very, very few limitations at the moment. Again, deliberately so, to see what people will do with it. So the Open Knowledge Foundation is scraping open clinical trials data. They were very kind of them to ask us first, we're about to scrape 2.4 gigabytes. Is that going to be okay? And we were like, well, we don't know. Give it a go. And it works. Again, every week at Morph, there's hundreds of thousands of web pages are scraped, millions of lines of rows of data is added, and tens of thousands of API calls are made. So nothing yet. We'll see how it goes.
Well, 2 gigabytes, it fits in the memory. It's nothing, right? Okay. What about proxies? If there's a website that limits the input IP, can you work through proxies or things like that?
That hasn't been an issue so far. So I guess it's a bridge that will work out when we come to it. Okay. Build when we come to it.
Okay, so this is not the question. 这不是一个问题哈，因为 G0V 的这个 OpenHAB model 其实已经可以从 DCAT 这个下载了，所以其实你已经有 JSON 档了，其实不必砍的，这样 OK。
I should have known that the Gov0 data portal does have an API.
Right. So 那下一个就是说 OpenRefine 这样子的工具，它事实上是可以已经把其他网站当做资料库，所以说有人是用 OpenRefine 或这些东西直接把你们 morph 在上面的东西当做资料库来处理。
So the question is, can morph work directly as a data source for tools like OpenRefine? And yeah, absolutely. I mean, the API is a JSON API. You can access that from any tool that you want. People build entire applications on it so that it acts like the database for that application.
Okay, so the last question. For dynamic Ajax, like Selenium or Phantom.js-based things, 如果它是就是动态产生，像 Gmail 这样的东西，你们砍得了吗？
Yeah, that's a great question. So about scraping dynamic web pages with JavaScript, if you look on the morph.io documentation, you can use a tool called Phantom.js, and that will run a headless browser on Morph that looks and acts just like a normal web browser, and then you can click around the page and scrape data off that page.
好，那这次给我们国际斧头帮助一个掌声。
Thank you.